Investigating population fluctuations in an ecosystem is an integrated curriculum unit. This unit has been designed in conjunction with an assignment requirement for the course Curriculum and Instructional Design for Diversity at American College of Education. As an overview, I will offer some background information. I will then provide the relevant learning objectives, aspects of curriculum design, alignment with Bloom's taxonomy, and benefits students will receive from using research-based methods in curriculum design and implementation. This unit integrates aspects of algebra, like linear equations and scatter plots, with those of biology, namely habitat fragmentation, resource depletion, biodiversity, and endangered species. I designed this unit with diverse learners in mind, specifically ELL populations. The unit also meets a handful of Virginia state standards across several content areas. The purpose and learning objectives represent a snapshot of the curriculum unit learning tasks that are highlighted in this presentation. The curriculum unit includes several learning tasks that are aligned with research-based best practices. The tasks can be characterized by Bloom's revised taxonomy as presented in an overview by Krathwohl in 2002. One activity requires students to read a news article about habitat destruction and fragmentation in Borneo and the subsequent loss of orangutan populations. Students use procedural knowledge, particularly regarding summarizing, as they are to identify the main idea and write their summary in their journals. Students also use the verb understand as they summarize the content that they're reading. Given actual orangutan population data, students will next create a scatter plot, identify lines of best fit, and answer analysis questions that promote critical thinking. It is important to note that students shall be placed in cooperative learning groups to discuss and complete the analysis questions. Groups will be tiered, and different tiers are assigned different sets of questions. This task requires that students use both conceptual and procedural knowledge, particularly knowledge of generalizations, theories, and models, and knowledge of the subject-specific skills and algorithms, methods, and techniques as they plot points and use a graphing tool to calculate the line of best fit. Students also use the taxonomy category understand as they explain their ideas and thinking and make predictions. A third task in the unit requires students to research not only orangutans, but also cougars. They're expected to write a report in which they describe and compare each organism's habitat, basic needs, and behavior. Students are required to use unit vocabulary words and will refer to a grading rubric to self-check. Students use several aspects of Bloom's analyze, including differentiating, organizing, attributing for this task. The unit assessment brings the idea of habitat loss and fragmentation closer to home, as my students are from Virginia, and the cougar is actually a predator that would be affected very similarly to the orangutan that is being affected in Borneo. Students will travel back in time to an undisturbed Virginia plot of land. They will have an opportunity to develop the land as a national forest. There are restrictions and requirements students must consider, including building requirements, recreation requirements, and ecological restrictions. Students will simulate cougar population fluctuations in their preserved 2 million acre land area, create a table and line plot of the booms and busts of the cougar population. The graph and table are both expected to be electronically produced using Google Sheets. Students must also explain how their proposed land use map would be different than how Virginia uses that land today. Additionally, a written rationale is required to accompany their cougar population data that explains why populations increased or decreased from one census to the next. Students will benefit from these learning tasks in several ways. Integrated curriculums tend to help students make deep connections they would otherwise miss. Students learning English benefit especially from this because language barriers make these connections even more difficult to make. The authentic nature of the assessment helps students engage cognitively in content, which promotes higher level thinking. This creates a deeper mastery of content for all students. Additionally, activities in the unit reflect Marzano's suggested strategies for increasing rigor. These include identifying similarities and differences, summarizing, and generating and testing hypotheses. All students benefit from cooperative learning groups. The groups are tiered for one activity, and students analyze their scatterplots through lenses that are custom tailored to their group. Not only does this help close any student knowledge gaps, this gives ELL populations an opportunity to engage in input and output communication with peers, which is essential for English language learners. These are among a multitude of benefits that students experience when teachers rely on research-based strategies to meet the needs of all learners. Thank you for your time.